Dear student, last experiment of your lab, that is the random forest, which is the ensembled classifier that we are going to see in today's video. Okay, and the exam point of view, both theory and lab internal or external lab point of view, random forest is an important experiment because in both of previous OU question papers, they have asked you to implement random forest. So here also, I'm not expecting a classification report or confusion matrix from you. At least you should be able to read your data set, find out what are the dependent, independent variable, then split the data set, and then train your data set and predict the target and find out what is the accuracy. Okay. These are the minimum cells expected from you during exam. Okay. Now, as usual, import all the required libraries for your experiment. Then read the data set. Here, I am implementing random forest on car data set, which is containing and the columns like buying, maintenance, how many doors are there, what is the sitting capacity of persons, what is the luggage good, how much it is safe, and what is its class. Okay, so that data set I have read using read CSV method. So these are the number of rows and number of columns available in my original data set. Now, when I am reading first 5 rows of that data set using head method, what I can see that one of the row is given as a column name, which I don't want. Okay. Now, what I want, what is the actual column name that should be given here? Okay. So for that purpose, I am defining a list of the column names, and then to your data frame, these column names should be applied. That's why I'm giving the df dot columns is equal to column names. Okay, then you can see that when again I am saying head properly, you are getting the data with the applied columns. Okay, now here what you observe, what kind of data you are having? Some columns are having numerical data and the remaining columns are having categorical data. So before going for implementing your random forest, you should convert the categorical data to the numerical data. Means it needs some encoding. Okay, so how we can apply that encoding? So define your X and Y. In X, don't consider the last column, that is the label of your data set, that is the class, because I want to consider it in the Y. That's why X is available with the data frame except column class. Y is having only one column, that is class. Then split your data set, applying the train test split function and get your train and test part of X and Y. Okay, and here you can see how is your 2/3 and 1/3 division. Okay, now to encode your numerical data, means to convert your categorical data to the numerical form. To do that encoding, I need category encoders. Okay, so when you are writing to import that category encoder, if you are getting error at this cell, that means that category encoder package of that library is not available in your laptop. Then you should install it either using pip command or either using the conda package. Okay. So I have used this command to install the encoders in my laptop. Now, what I am doing? I am performing ordinal encoding. Okay. Now, in ordinal encoding, what I am doing? I want to apply the ordinal encoding with all available columns. So I will call the ordinal encoder method, and then it will be applied on both train part as well as the test part. Okay. Now here you can see after applying the encoding, I'm not seeing any string value. So based on your options. Now what are your options here? Very high, then no. Low, high, medium, like that. So based on that, you will get the values encoded as 1, 2, 3 based on the availability of your options. Okay. Now you have obtained the encoding in both training split and the testing split. So that you should ensure by calling the head method. Okay. Now, this is the main cell where I am implementing my random forest. Now, first of all, let me explain you. Random forest is the ensemble version of your decision tree. The decision tree is containing only one tree, okay, in which I'm splitting my attributes. Means first I'm deciding the root of my decision tree by applying the entropy and information gain as ASM, that is the attribute selection measure. Okay, now once root is obtained, then I will find out the left subtree and right subtree. Means I will go on doing this splitting by applying the same formula of entropy and information gain. So like this, I will get one decision tree, but the accuracy of decision tree is not satisfactory. Then in that case, I will go to the ensembled version to improve my performance. So that is what your random forest, in which randomly columns from my data set will be picked up and they will be given to the each of decision tree. So the combination of this multiple decision tree is what my random forest. Okay, so call your random forest from your sklearn. Now, whatever random forest you have obtained, train it on your X train and Y train, then predict the value, you will get the Y predicted. This is your predicted output. Now you should find out the difference between the actual output and the predicted output using the evaluation metric, that is the accuracy score. So here you are getting your accuracy as 96.49%. Okay, so these are the minimum cells expected from you in exam. And if you need, you can go for in estimators also. Means for your random forest, instead of only passing one variable as a random state, you can pass one more efficiency variable, that is the n estimator, and that is equal to 100. Here I am taking the sample of 100. Again, repeat your fit part and the predict part and find out the accuracy. There is no change in the accuracy obtained. Okay. Now, what I want to view what is the feature score. Means for each feature, how much importance is given here. Okay. So for that purpose, from pandas, by applying the series method, I can find out the importance of each feature in my train part. Okay. So these are the feature scores, and even those will be plotted by applying the bar plot method in Seaborn package. Okay. So here you can see it, the feature score. Okay. So these are all the extra cells which are not part of the minimum implementation. In minimum implementation of your random forest, I am expecting that you should be capable of reading the data set. You should be capable of changing its column name. You should find out what is the dependent and independent variable. You should split your data using the train-based split method. Then encode that data. That is the ordinal encoding. Then fit your model for the training part and testing part of X. Then find out what accuracy you have obtained by using the random forest. Okay. So this is what means, at least up to this cell, you should be able to do the implementation. Means in exam, I will like to see you accuracy of the random forest. So this is the minimum preparation expected from you. So till now in lab part of advanced machine learning, we have seen how we can reprocess a data set, how we can develop a ANN model using inbuilt backpropagation, how we can develop the same model by doing the manual calculation, that is the forward pass and backward pass, how we can improve the performance by using the hyperparameter tuning, and how we can develop an ensembled version of any classifier, that is the ensembled version of the decision tree is random forest that we have seen. Okay, so these are the 5 labs the student have implemented on different data sets, so that they will get more practice. So these are the 5 labs expected from you during lab exam. Thank you.